So today we're just going to be looking at some algebra. So we're going to have a quick explanation of the methods we use to solve problems involving algebra, and then we're going to move on to some worked examples and then on to some practice problems. So firstly, we're just going to talk about sign conventions and what happens when you multiply numbers of certain signs, either positive or negative, together, or when you divide numbers of different signs, either positive or negative. So the general rule is, if multiplying or dividing numbers of different signs, what you want to remember is that a plus and a plus makes a plus and a minus makes a minus, and a minus makes a plus. And of course these can be written the other way around as well. So this is the general basic rules involving signs that you need to know. So in a quick example, if I were to write 5 times 5, these are both positive numbers, so that would equal 25. That's the one that you're probably most used to. But if I were to write 5 times minus 5, you can see here that now we have a positive and a negative, and these will multiply together to give you a negative. And now, if I were to say minus 5 times minus 5, these would multiply together to give you positive 25 again. So an easy way of remembering this is, same signs give you a positive, different signs give you a negative. Another thing I wanted to mention is some shorthands that we use to make life easier for us when dealing with algebra. So if I just give you the letters A, B and C, where A, B and C can represent any number, that's the meaning of algebra. It's writing letters that can represent any number. Now if I wanted to express A times B times C without writing the times signs in the middle, I could simply say A, B, C. And it is implied that because there is nothing in between each of these letters, a multiplication sign is implied in this. Obviously, the hardest thing to get your head around is the fact that we don't do this with normal numbers. So if I wanted to write 2 times 2, writing 22 is obviously very different. So this is the primary difference between when dealing with algebraic letters and when dealing with numbers. It's the fact that we can use these kinds of shorthands. Something else is, if I were to write A squared, this is equivalent to writing A times A, now this kind of thing becomes particularly important when dealing with expressions in brackets, because if I were to write A plus B squared, this would actually be equivalent to A plus B times A plus B. And again, in terms of notation, writing brackets next to each other also implies times. And now this is slightly easier to get your head around because this does also work with numbers. So if I were to write 2 squared, that is equivalent to writing 2 bracket 2. Where you have 2 brackets next to each other, a times is implied. And obviously this works for any power. So if I were to write A plus B cubed, this is equivalent to A plus B times A plus B times A plus B. And now if you're asked to write this out explicitly, so if you were asked to show that you know what writing 2 brackets next to each other implies, it could always be good practice just to write it out longhand until you get used to the notion. So all these 3 expressions here are equivalent to one another. It's just a matter of notation. Of course this one is preferred because it's the most compact, but in an exam you might be asked to simplify or write the operations of the implied expression, in which case you would write this, because it is asking you whether you understand what this expression actually means, and it means it's a plus b, whatever is inside the brackets, times by itself 3 times. Another very important thing involving algebra is the ability to collect like terms, and that's just a fancy way of saying putting things that are the same together. So if I were to, I'll explain this by way of a quick example. If I were to write 5x plus 3y plus 2x plus 2y, what you have to try and imagine is that x and y are different things, but they can still represent any number. So in collecting like terms, all that means is collecting together things that are the same. So here you can see that x is the same as x and y is the same as y. So to collect these like terms, I just have to add 5x and 2x together, because you can see that they're the same because they both have x terms in them. And 5 plus 2 is of course 7x. And then you can see that here you have 3y and 2y. And again, the y's are the same. So you can just collect these together to give you plus 5y, just simply doing 3 plus 2. Now things get a bit more complicated if you have squared terms in them. Now this is an important point because this is where students mainly go wrong. So if I were to write 2x plus 2x squared plus 5x plus 5x squared, students often look at these and think x appears in all of these and they will simply add them all together. But it is very important to note that x squared must be treated as a separate thing. It must be treated as though it is different. So you can essentially treat this as in the same way as you would treat 5x plus 2y plus 5x plus 5y, where I'm just using y to represent x squared. So if I were to collect like terms in this expression now, I would end up with 7x plus 7y. In the same way, if I were to collect like terms in this expression, I would end up with 7x plus 7x squared. The important point being you must treat x and x squared as if they were different. And also if you had x cubed terms or x to the 4 terms or any different power, you must treat every different power as though it is its own letter, essentially as if it is its own algebraic notation. So now we're going to move on to some examples. So this question is asking you to evaluate 10 plus minus 5 minus positive 4 minus negative 2. So this is just getting you used to the idea of combining different signs. So first of all, you have to look at each sign pairing individually. So here we have a positive and a negative multiplied together. Here we have a negative and a positive. And here we have a negative and a negative. So this positive and negative here will give you a negative. This positive and negative here will give you a negative. And this negative and negative here will give you a positive. And remember, different signs give you a negative. Like signs give you a positive. So now we have 10 minus 5 minus 4 plus 2. And now this is just some simple maths. So you end up with 12 minus 9, which is equal to 3. So moving on to the next example, now we're introducing the algebraic part of this. So it's essentially the same question, but we're using letters to represent numbers. Again, you have to look at each pairing. And of course it's important to note that if nothing is written, this of course implies that it is positive. So minus x is the same really as writing minus 1 times positive x. And the pairing of the signs is this minus and this positive, this plus even. So this positive and this negative give you a negative. this negative and this positive give you a negative, this negative and this negative give you a positive. So just like the last question. So now I can say that this is x minus y minus x plus y, which evaluates to 0, because I have x minus x, which is 0, and y minus y, which is 0. So moving on to this example, we have to notice that we have brackets written directly next to each other. And remember that when you have two brackets written directly next to each other like this, it just implies that there is a multiplication between them. So this will expand to positive x multiplied by negative y minus positive x multiplied by negative y. And now it's important here to remember your BODMAS rule, which states that multiplications must happen before minus signs. So we perform these sums, if you will, inside these brackets before performing this minus here. So we do positive x times negative y. So positive times a negative will give you negative xy. And this positive x and this negative y will give you minus, because there's a minus here, negative xy. You see, things are getting a bit complicated now because you have to remember that this negative sign is still here, and be careful not to simply write this one negative on its own. You have to keep track of all your minus signs. So now you can perform this minus, and now we see we have a minus minus situation. So really we have minus y plus xy, or minus xy plus xy, which equals 0. Because these are like terms, xy is the same as xy. So this is like writing minus 2 plus 2. These are the same thing. So a negative version plus a positive version gives you 0. So now moving on to the next example. This is just to get you used to the idea that writing things next to each other implies multiplication. So if I were to rewrite these two things to show all operations, I would write ABC equal to A times B times C. And I would rewrite this expression ABC Q minus P squared as A times B times C times, remembering to keep the expression in the brackets separate and treating it as if it were a single thing, times Q minus P. This is another thing where students might get tripped up. It's the idea that anything inside a bracket can just be treated as its own single thing. So now moving on to the next example, simplifying this expression. So again, we just have to collect like terms. So looking just at the x terms to begin with, we have 4x plus 2x minus essentially 1x, which is going to give me 4 plus 2 minus 1, which is 6 minus 1, which is 5x. And then just looking at the y terms, you have 6y plus 10y, which gives you 16y. So this whole expression goes to 5x plus 16y. So now moving on to the next example. Again, just look at your x terms first. So you just have 2x. Then you look at your x squared terms, because remember we must treat x squared differently to x. We have 4x squared plus 2x squared, which gives you 4 plus 2, which is 6x squared. Now looking at your y terms, you have 5y plus 4y, which gives you 9y. 5 plus 4. So now rewriting all these things together gives you 2x plus 6x squared plus 9y. Moving on to the next. This is now a practice problem. So if you'd like to pause the video here and then play it when you think you've got the answer, and I will go through the worked solution. So first things first is to look at all your sign pairings and work out whether we have a multiplication situation, a plus situation, or a negative situation. So this 3y out front is clearly just positive 3y still. Now these brackets are not directly next to each other. There is a minus sign between them, so this is not a multiplication. This is simply a minus minus situation. And of course a minus and a minus gives you a plus. Here again, they're not directly next to each other, so you just have the plus minus situation, which gives you minus. Here, minus and a minus gives you a plus. Here, minus, and because there's nothing written, again, it implies that it's positive, so we have a minus and a plus, which gives you minus. And again here, minus and a plus will give you minus. So now collecting like terms, if I collect all the y's together, I have 3y plus y minus 4y, which gives me 4y minus 4y, which of course gives me 0. Then collecting x terms together, I have minus 2x plus 4x minus 2x, which gives me 4 minus 2 minus 2, which is again 0. So this entire expression equates to 0. So moving on to the next practice question. Again, pause the video and play it when you would like the answer. So here, the PQ is the easy part. It's just P times Q because they're written next to each other. And then you have to remember again that because there's nothing there, it implies multiplication. And this 3 tells you that you're multiplying this bracket by itself 3 times. So you treat the thing in the bracket as a separate entity. R minus 2t multiplied by itself 3 times. Now we're getting a bit trickier. So now we're being asked to simplify a more complicated expression involving multiplication of different signs and rewriting to show the different operations. So the first 3 letters are simple enough. P times T times R times this expression that I'm going to put in square brackets just for clarity. A square bracket is exactly the same as a round bracket. It's just they're used when you have expressions within expressions such as this. So now I'm just going to deal with the signs first of all. So we have 2x squared plus 5x, and now we have a minus 2y multiplied by minus 2y, which is going to give me a positive 4yx, and then we have plus 3xy and plus 8x squared. Now it's important to notice that although this says yx and this says xy, of course the order of multiplication doesn't matter. 2 times 4 is the same as 4 times 2, for example. So here we can say that y times x is the same as x times y. So although these are written in different orders and may look different, these are in fact the same. These are like terms. So you can simply say that these 2 terms here give you 7xy, just doing 4 plus 3. So now rewriting the entire thing gives me 2x squared plus 5x plus 7xy plus 8x squared. And now we notice that these are like terms. 2x squared and 8x squared can be added together to give you 8 plus 2, which is 10x squared, plus 5x plus 7xy. Now this would be far enough in this question, but if you wanted to be explicit, you could of course say that this x squared is also x times x, and you could also write this as 7 times x times y, and this as 5 times x, if you wanted to write every operation. So that's all for Algebra Basics. Feel free to drop any questions you may have into the comments section, and I'll get back to you as quickly as I can. Thank you for watching.